So what you're seeing here is that you're seeing the Canvas 2A webpage. And what I'm hoping that you did is that you had a little bit of chance to read over this course information. It says here, teaching with the Nielsen replacement, we want to look at the welcome and overview of Physics 2A. There's a syllabus, there's book recommendations, and then there's some words of advice. So I'll try to go through this quickly so that we could move on and get into the physics here. So let me start off here with teaching with the knee replacement. So the idea here is that I have an estimated timelines of how I want to run this course. So for the first 3 weeks, with consultation with my physical therapist, not my surgery team was very unrealistic. And the physical therapist had more realistic goals. So for the first 3 weeks, I expect to be online and teaching here from home. By that time, I should be able to stand somewhere around 10 to 15 minutes so that if I teach with my tablet from home, from the classroom, if there's a demonstration after that, I'll be able to get up and do demonstrations and stuff like that. So again, like I said here, I am not expecting that these are hard lines. It could be a little bit longer, it could be a little bit shorter, but after that, I should be face-to-face, I assume, by the 18th. And that includes being in the lab and being in the lectures. Okay, so you can read a little bit more of the details in here. So then if I come back here to the overview of this course, then this is what I'm thinking here. I've been teaching a long time. I've been in academia 34 years. This is my 25th year at Cabrillo College. And you could see this by the gray hair on my head. So I've been around the block a couple of times. So what you're seeing here is that, again, lectures are Tuesdays and Thursdays. Up till the 14th, I expect it to be on Zoom. After that, I expect that we'll be meeting in room 804. All of these lectures that I have online will be recorded and uploaded to YouTube, where you'll be able to access them. There are 2 lab sections. There's 2A1, which is at 9:30 to 10:50 Tuesday and Thursday, and then lab 2A2, which is 11 to 12:10. I think is that 11 to 12:10? I think that's right. And you'll be able to, so these are every Tuesdays and Thursdays. All quizzes and exams will be done on Canvas. So we got to be careful when we say on Canvas, because it can be real tricky. So what ends up happening here is that, it says that, let's say that I give you an allowed time of 45 minutes. That means you'll have to write a solution, and you're going to have to create an image within the 45 minutes. Some people say that that is not enough time. I want to say that before COVID, we had face-to-face quizzes, and quizzes maxed were somewhere between 20 and 30 minutes. Those quizzes have not been made shorter or longer. They're the exact same length. So I'm actually giving you, 10 to 15 minutes to create an image. So my experience is that this is enough time. So you gotta allow the ability to create an image and upload it. Now, quizzes and exams will open at 6 a.m. and they're going to close at midnight the same day. Okay, so you want to pay attention to that. Now, one of the things that we should look at is that I have problems with the student. Some of the problems that students have here is that they have issues of, like, for example, not being able to upload more than one page. So how can I upload more than one page up to Canvas? Well, one thing that you could do is that you can create a PDF after you take an image, or you can have multiple images that you can create into one. If for some reason you're on a time crunch, then this is the idea. If you go over here and you click on grades, what you're going to see here is that you'll be able to go and you're going to, Canvas is really slow. There's a message on my Canvas that says that there's a really backlog on Canvas right now. So what you'll do here is that when you click on that, look at that, I am not able to go all the way down. I should have a test student right here. And I'm not seeing a test student anywhere. So what I'll do here is that I'll just pick this person since there's no grades. So if I pick, let's say, Diego Vasquez, if I click on this, here's what you're going to find. When you hit this, you want to go to grades. Okay? If you click on grades, this is what you're going to see here. Now, if you go to quiz 1 here, what you're going to find here is that if you click on this, what you're going to find here is it's going to give you the submission details, and you could see that there's an attached file here. Go in and attach the file, and if you, let's say that it's midnight, and you attach it at 12:01, 12:02, 12:03, I'm not going to care. But if you attach it at 1:30 in the morning, I'm going to care. That's really late, and I won't accept the quiz. But then, so attach, go into your computer, find that extra file that you have to attach and attach it right there. If you add a comment, I won't see it. If you want me to see it on Canvas, you have to send me an email and tell me that, hey, I uploaded it. But most of the time, if you did this, fairly quickly, right after the quiz ended, then I will see it, and you don't even have to put a comment. I'll just say, okay, there's your quiz. But that's the way you want to do that. So when I talk about submitting, more than one sheet for quizzes and exams, as well as for labs or problem sets, that's the way you want to do that here. So problem sets and lab write-ups, they're exactly the same way. You can upload them into Canvas. I'll talk about PLC assignments in a little bit, but PLC assignments, you are required to spend 50 minutes a week in the STEM Center, and you'll see that there's a section there that's called the PLC. Do you have to do it in the PLC section? Of course you don't. But when you complete a PLC assignment, it has to be checked off by an instructor of a PLC in the PLC section. And again, we'll talk about that in a minute. So let's go through the syllabus briefly. Okay, so that's basically the overview. So if I go to the syllabus, by far the best way to do is hit me through email. I have a telephone number. Well, for the first 3 weeks, I'm not even going to be there. So that's definitely not the way to call my office. And even when I'm there, I'm typically not in my office because I'm either in the classroom, the lab, or the PLC. My office is on 813, and the Cabrillo email works best for me. The Canvas email, personally, really sucks. It is the worst possible email you can have. You could send me emails through Canvas. I prefer the emails through cabrillo.edu because it's Gmail, which is considerably better than the Canvas one. So here's some basic course information, right? We're talking about Physics for Life Science 1. Everybody has gone through the prereq, so I won't have to worry about that. Here's a link to the lecture, office hours, and if you have problems with Canvas, this is the place to go. Let's talk about the textbook. The textbook that I like is called College Physics, A Strategic Approach by Knight, and I think it's the best book on the market by far. Not by a little bit, by a lot. So here's my thinking on the textbook. When you come over here to the course information, here's this recommended textbook. So here's the one that I recommend, but maybe you have another textbook. Any other algebra textbook works just as well. The information is about the same. So, but the reason why I like Knight better is he uses a lot of the research done into physics learning, whereas all of these other textbooks don't. That's why I prefer Knight. Now, let's talk about this. As I've already said, I've been at Cabrillo for 25 years. It's really clear that the majority of the students do not read the textbook. So if you don't read the textbook, why are you going to buy it? I was looking at the lower end of the textbook at Cabrillo College bookstore, and it was somewhere between $200 to $250. That's a lot of money to pay for a textbook if you don't read it. You should only buy it if you read it. Now, let me show you what I know here. Past experience has shown me that most students rely on my lectures and personal lecture notes. In the beginning, I'm going to be posting YouTube video lectures with the notes along with them. And then later on, I'm going to post my personal lecture notes that I did in Word. Furthermore, there's lots of YouTube videos that are really great. I encourage you to find what works best for you. But my experience says that people can get enough information from my lectures to complete all the problem sets, pass the quizzes, and the exams. Should you buy the textbooks? Of course, I think you should buy the textbook. Only if you read it. As I said already, I'm going to post everything online. So I did not choose to list the book at the Cabrillo bookstore because it was way overpriced. So the current edition of the textbook is the 4th edition. Okay, it's the 4th edition. So I just looked at Amazon. By the way, there's about 5 or 6 other sites that I didn't list here. Amazon had about 30 copies of the 4th edition at this Amazon link. And when you look at them, go to the link that says other used or new from, and I found 30 between $7 and $20. It's a used textbook, but it's still the current edition. And there were a lot of other textbooks that went up to $30, and there was probably about another 30 of those. That is a considerable savings compared to trying to buy from the bookstore. That's why I refuse to put it into the bookstore. Okay, that's my philosophy on the books. Now, going back to the syllabus, I've now dealt with the textbook. Here's the learning outcomes, which I'll let you look at, and you'll be able to sort of like see what you should be able to do when you leave this course. Let's talk about academic honesty. Plagiarism and academic dishonesty after COVID has been rampant. So if you click this link, you get this image that I clipped off this with plagiarism and academic dishonesty. And I strongly encourage you to read it and understand what it means. And so when I say this here, it says collaboration on quizzes and exams or plagiarizing the work of a colleague or a website is strictly forbidden and will result in the failure of this class and the full extent of disciplinary action allowed by the college. Let me give you examples. This summer, I taught Physics 4C online. I had 48 students, And what ended up happening is that I found that there were groups of people, let's say groups from UCLA, groups from Berkeley, groups from Sacramento State. All of these people decided to take this class, and they worked as a group, which I strongly encourage. So what ended up happening, some of these people decided to collaborate on quizzes. So here I am, they upload their quizzes, and guess what? I really couldn't tell one from the other. So in other words, they cheated on the quiz. So you know what I did? I dropped them from the course, I gave them an F, and I reported them to the college. They knew exactly how I felt about collaborating on quizzes. Furthermore, there were some people that went online and tried to answer questions from other websites. And what you found here is that some of these people found websites that were exactly the same, and they had the exact same answer. A little bit of search, and I found that site as well. So guess what? Because they cheated on the quiz, I dropped them from the course, gave them an F, and reported them to the college. So what do I recommend that you do? Don't cheat. I'm here to protect the people who are honest. You know, and so what you want to do here is that if you look for, let me just give you an example. So this summer, I started with 48 students. I finished with 35. I failed 6 people because of cheating right away. You want to be careful, because even though it's online, it's a lot easier to catch people cheating. You also got to be worried about some of these sites that provide answers. There was one quiz that I gave that had, that said Carlos wore, sharp pointy boots chasing cockroaches at a cheap motel, and I asked for what was the speed of Carlos running to catch the cockroach. And guess what? I did an internet search and I found multiple sites where people had submitted the solution for the quiz. Little did people know that I could go into these sites and request the email. And guess what? I found out that those students were in my class. So what did I do? Dropped them from the course, gave them an F, and reported them to the college. Collaboration and plagiarism is serious in academia. Okay, so I hope I'm clear with that. Now let's talk about the non-discriminatory and accessibility notice. The thing, I'm going to let you read this, but the thing that's important here is that if you require accommodations from the Accessibility Support Center, you want to make sure you get that done early. And if you have the ability to have those accommodations, I strongly, strongly encourage you to get them. It evens out the playing field. It's super important that you do that. Okay, let's go to grade assessment. So when you look at how I'm going to base your grades, you can see here it's over problem sets, PLC activities, lab reports, quizzes, exams 1 and 2, and a final exam, which is a comprehensive final. Now look at those weighted percentages. You could see that they're evenly spread out. Problem sets and PLC activities are 10%. Lab reports, quizzes, each exam and the final exam are worth 16% of your grade. It is purposely done this way to spread the grade out. So let's look at problem sets. In my opinion, without any doubt, the most important part of this course is problem sets. Without a doubt. If you cannot master the problem sets, you passing this class is very low. And you could see here, because the problem sets depend on, look at that, there's quizzes, there's the exams 1 and 2, and then there's final exam. That is 64% of your grade. How you do on the problem sets reflects how you do on quizzes, exams, and the final exam. It's the most important thing. So how am I going to do with problem sets? You have to upload them into Canvas. Your success will depend largely on the effort that you invest in these. The problem sets will be graded between 0 and 4 points. So let's go to here. Now let's go look at the problem sets here. So if you go to chapter 1, you'll see here's a link for problem set 1. So problem set 1, you'll see that there's a link for docx file or PDF that you could download. Now, what's special about the docx and the PDF, they don't have solutions to the problems. The only solutions to the problems are here on the website. Now, what you're seeing here is that the problem sets are a combination of questions and problems. The questions are conceptual in nature, which means you have to write short, concise answers as well as pictures to answer these questions. Problem sets in general require some type of mathematical solution. So if you look at problem set 1, you're going to see here is that if you complete this, and if I have the correct answer, this should match up with what you should be getting. And you'll see that all of these problem sets, if there's an answer available, is right there. So your job here is to complete these questions and problems and upload them to Canvas. Now, again, if you have trouble uploading these guys, add it to an attachment. If you're having trouble adding more than one sheet here. Now, I have one other thing about the problem sets, and it's here in the course information where it says words of advice. Okay? I'm going to let you read the first paragraph. Okay? But this is the important piece right here. It is imperative that you keep up with the problem sets. Proficiency with these concepts only comes with sufficient practice, and the concepts build on each other. A word about the problem sets. It is not something that you just throw together and turn in to get points. Problem sets is crucial practice for quizzes and exams. I want you to work. I want the work you turn in to be neat and organized. I want to see the work used to solve problems, not just the answers. Let's say that again. I want to see the work, not just the answers. So if you're giving me the answers on the problem sets, I might probably say, okay, I may not. But if you get to the quizzes and the exams and you do exactly like you did on the problem sets, if a problem is worth 20% and you give me an answer, you know what I'm going to do? If you just give me numerical numbers, I might give you 2 out of 20 points. How do you get the other 18? I need to see the work that you use to solve the problems. Answers are not sufficient. I'm interested in how you think, not the numerical answer that you got. Your work should be clean with good space between steps. Don't try to save paper by cramming everything into as tight as possible. Make an effort to turn in something that you're proud of. I promise you the added effort will result in improved study skills that will bring rewards throughout your entire educational career. Super, super important. Practicing on problem sets gets you ready for the quizzes and exams. Let's go back to the syllabus. So you can see here, we've now talked about problem sets, and here's the basic rubric. Quizzes and exams are exactly the same. They have to be completed online. They open at 6 a.m. They close at midnight of the same day. The quizzes are open book and open notes. Again, we talked about plagiarism and collaboration. I'm expecting the honor system. So I expect there to be somewhere between 8 to 10 quizzes, which roughly makes each quiz about 2% of your grade. Final exams operate exactly the same way. Exam 1 is going to be over the first 6 chapters. Exam 2 is going to be over the next 4 chapters. And then I'm going to have a comprehensive final where we're probably going to cover about 15 chapters. So that's roughly about 1 chapter per week. Now let's talk about PLC activities. A PLC activity is a drop-in TBA open lab hours. So I think to give you a sense of why we use a PLC here at Cabrillo, let me give you some history about it. About 22 years ago, there was a guy named Doug Brown who was an instructor like me here at Cabrillo. He went on a sabbatical and he went around the country where he stopped in and looked at different universities and what they did to encourage students to succeed. He found that the programs that were most successful where you set up systems so that people worked in small, effective work groups. And because of this, this Physics Learning Center was born. At the time, Physics 11 and Physics 4A, as well as Physics 2A. Physics 2A had a higher pass rate. I think the pass rate in Physics 2A was something like 70%, but the pass rate in Physics 11 and Physics 4A, which was the introductory part of the course, Physics 11 and the Physics 4A are typically the people that are going into the sciences and engineering, like physics or computer science, etc. And they had a pass rate of a little over 60%. When we implemented the PLC, after about 3 years of sort of like making a lot of mistakes, we got the pass rate to go from the low 60s to the low 80s to mid 80s. That was a significant increase. Because of that, we then implemented in all of our courses. So PLCs are designed to support conceptual learning of the material using ranking and applet questions. And we encourage, right? Our experience shows that it's best to work in small groups. That's why we use the PLC, because the pass rate has been considerably better. What we'll find here is that there are 12 to 13 PLC assignments throughout the semester, and typically it's roughly 1 per week. Some weeks you won't have a PLC, and Physics A is required to do 50 minutes per week that have to be done in room 834. So what does that mean? Well, what that means here is that if we look at, if I go into the PLC assignments, let's go to chapter 1, and you're going to see this week there's a PLC on significant figures. So this is something that I just assumed that you already know. But this is just a review. So if you look at this tutorial, it gives you a tutorial on the use of significant figures the way physics does. I know that chemistry uses quite a different way of looking at sig figs. Now, if I go back, you'll see here is that there's PLC1. So PLC1 has a due date of September 5th, which is next Tuesday. It turns out that we are not allowed to have a PLC the first week because we can't hire tutors to check off PLCs. So the idea of the PLC is that you walk into the PLC and you have to first sign into a computer and sign out when you leave. And by the way, that's super important because that's going to show whether you were there for 50 minutes or not. Once you have completed this significant figures PLC, you want to now go show your work to a PLC tutor or an instructor. They're going to check the work off. If the work is not all completely correct, they're going to give you back the PLC and it says you have to fix this. So then you go back with your group and you fix it. If your PLC is completely correct, they're going to check your work off and they're going to initial a sign-off sheet. And then that's it. You don't have to turn it in. It's just you're completed right there. Initially, working in groups is going to be pretty hard. Why? Because I'm assuming that you probably don't know anybody in the class. But as you go to the labs, and typically, you know, if we had lecture face-to-face, when you go to lectures, you're going to start to recognize people. And my experience is that people who go at the same time every single time into the PLC will start to recognize who's in physics 2A, and hopefully they start to work together as a group. But this first one, I would expect that most of you are going to just work by yourself. But after the first PLC, I'm going to strongly recommend that you do work as a group. So when you go back to here, you're going to see that this one is this PLC is the 5th. The second one is going to be on the 8th. So there's going to be 2 in 1 week. So one will be due on Tuesday and one will be due by Friday. But that doesn't mean that you can't do it by Thursday. Okay, so that's what I mean by the PLC. It's working in these small groups that becomes really important. And our success rates have increased dramatically as a result of that. So now we've talked about PLC activities. Now let's talk about the lab. Labs are going to be uploaded and they're going to be due every Tuesday by midnight. So there's going to be about 12 to 14 labs. Labs start today. They're going to be live, and you're going to see that the labs are, in the beginning, are going to be pretty self-explanatory. Today's lab and Thursdays is very, very intuitive, where we're going to try to get you to internalize what does it mean to measure things in the metric system. Paul and Julia are going to be running the labs in my place here. So as we get into next week lab, I will help you on what you're going to have to put into the lab report. But for right now, this week's lab is pretty self-explanatory, as you'll see. Like, for example, if I come here and I look at the lab, you're going to see that the first thing that you're going to do is that you're going to do some team building. That's the important thing. And this is going to be a short period of time. And then the big part of the lab here is that you're going to focus on trying to get intuition on lengths. So you could see that you're going to measure something by the following procedure. You're going to guess what that is in terms of, you know, 2 reference lengths. You're going to have the diameter of a penny, which is 2 centimeters, and you're going to have a length of a meter stick. And then you're going to start to choose appropriate units. Like, for example, what's the diameter of a wire? You're going to guess it, and then you're going to use the right units, and then you're going to measure it to see how well your guess was. It's very, very simple. A nice little table will be, perfect. And then you're going to look at a ball bearing and you're going to do the same process. So here, this is a fairly self-explanatory. Then you're going to do the same thing with speed. Then you're going to do the same thing with masses, where you have references. A paper clip is a gram. You're going to have 100 gram and you're going to have a kilogram. And then you're going to look at these masses and say, what's the mass of these things? You're going to look at volumes. So what you're going to find here is that this is just to build intuition. So it's a very, very light lab. So that's the syllabus right there. So we are now done with the syllabus. So what I want to do here is that I want to come in and I want to give a very brief introduction to sort of like an overview of my view of what physics is. Okay? My view of what physics is. So let me get started here. I had to restart my machine and I had everything set up, so I apologize for not being completely ready here. Okay, so what I'm going to do here is that I'm going to come in and I want to sort of like talk about, the overall course and what does it mean here? And so how's my viewpoint? So what I'm going to do here, man, I'm going to change my share. I'm not paying attention to the chat, and I just realized that so I just saw that there's some couple of questions and in the chat, and I apologize for not answering this as we've been going along. So the question is, do we know the hours of the PLC yet? The PLC in the past has been open Monday through Thursday from 9 to 6 p.m. On Fridays, they were open from 9 to 4, and on Saturdays, they were open from 12 to 5. I'm assuming that those hours have not changed. There was some talk about expanding those hours. So then the other question that was asked here is collaboration for all other assignments that are not quizzes and exams permissible? Absolutely. I want you to form small work groups. Okay? I want you to form small work groups. That's what it's one, it's more fun than working by yourself. And two, people who work in small work groups are more likely to do better in the course. The research behind that is huge. So please work in groups. I strongly recommend that. I will always have office hours. Always have office hours, including this week. I will always be there. Okay, so now what I'm going to do here is that I'm going to share my screen. And, okay. Oh, come on. For some reason, it's not allowing me to share here. Let me see if I can. Okay, you should be able to see my screen now. So let's look at this thing here. So the first thing that I want to do is that I want to just, I would say that this is an introduction here to the course. And if I was to think about my organization so far, I would say that the first thing that I did here is I talked about the course details. And if you ever have a question on the course details, you could go back to the syllabus, and I take the syllabus, I treat that very seriously because that is a contract between you and me. I can't change the syllabus ad hoc. 2, what is physics? There's a lot of people that think that physics is math, which of course it's not. And even though you may already know this quite well, I want to look at the scientific method briefly. If I was face to face, I would have done a demonstration with the scientific method. And then the last thing that I want to look at is I want to compare mathematics versus physics. Okay. Okay, so here we go. So I've already looked at the course details. So the first thing that I want to ask here is, what is physics? What I would say here is that physics, without a doubt, I would say that it is the study of all nature at its most fundamental level. And because of this, it's the basis of all science. Mathematics is not a science. Physics is a science. Chemistry is a science. Biology is a science. So I would say that definitely the basis, without any doubt, is physics. And what's special about physics here is that there are very few principles. So physics is driven by a few principles. Now, if I was to continue to move sort of like in a flow chart here, if I was to compare this to chemistry, for example, chemistry is not fundamental because chemistry does involve atoms, but the vast majority of the chemistry does not involve the whole part of the atom. They deal with the electronic structure of the atoms. For example, in physics, you find if you deal with atoms, not only do you deal with the electrons, you deal with the protons and the neutrons inside the nucleus. And if you look at the most fundamental level of what happens inside the nucleus, inside the protons and the neutrons, you can break those down even further and go all the way down into the quarks. So to try to understand what happens into the nucleus, we look at what is called quantum chromodynamics, which is the study of the quarks. And once you understand how the quarks behave, we then look at how the behavior of the neutrons and protons behave inside the nucleus. That is more fundamental than chemistry. Whereas chemistry, as I already said, the vast majority of the time, they deal with the electronic structure. Furthermore, what I find here is that chemistry, it requires many pieces that have to be remembered. I have a bad memory. Chemistry doesn't work for me because I can't remember all those things that people do. So I would say that chemistry involves physics and it involves chemistry. There's two pieces to chemistry. Now, if I was to go down the chain just a little bit more, and I'm only going to go just a tiny bit, we can get to biology. Biology, without any doubt, is an integrated science. For example, if you look at the heart of the when you look at the heart, there's a piece of the heart that requires physics because the heart is an electrical pump. You create a positive and negative right through the heart here. And furthermore, you'll see that in order for the heart to pump, you have to move ions. And in these ions, people are talking about chemistry. Okay, people are talking about chemistry. Okay. There's a lot of noise here. I'm going to try to. Yeah, I was going to try to mute everybody, but I'm not seeing it. Zoom has changed here. And then the other thing that you need here is that you also need the biology part where you have, like, let's say muscle contractions or whatever it is. Biology is clearly an integrated science here. That's why I say physics is the basis of all science. So let's briefly talk about the scientific method. The scientific method, when you think about the scientific method, most people say that it's a three-step process. I would say that in practice, it's a 4-step process, not 3. And so what I'll do here is that I'll start off with step 0. And what happens is that one identifies something very interesting and you know very little about. So something has to interest you. So then we go through what most people call the scientific method. There's this hypothesis. And a hypothesis is an educated guess. There are people that say, I have a theory. That's not the way it works in science. You do not have a theory. You have a hypothesis. That word theory is so misused. It's a hypothesis. It's an educated guess. Once you have a hypothesis, then you start the process of trying to understand the thing that you know very little. From your educated guess, you make a prediction. And these predictions in general are very weak. And what you find here is that this prediction is a consequence of the hypothesis. And what happens here is that this is a very, very interactive process. So from the hypothesis, you make a prediction and you think about it and you go like, oh man, that's not right. So you go back and you change your hypothesis. And then you start to make consequences again of the hypothesis and you go, nope, that is still wrong. So there's this back and forth again and again and again. And once you have done this numerous times, by the way, this is exactly what you're going to do on your homework. On your homework, you're going to make a hypothesis of how do you think you're going to solve this problem? And then you're going to go try to do that. And guess what you're going to probably find? That you didn't understand the process whatsoever. So what happens? You got to go back and you got to change what you initially think. So you're going back and forth. You wouldn't call that you have a theory. You have an educated guess how to solve the problem. The same thing happens in the scientific method. And once you've done this numerous times, not just I have a prediction, but you have gone through the details extremely, you then get to the most important piece of the scientific method. You perform an experiment. Experiment is the truth. And what it does here is it tests the prediction. This is the core of science. It is not science if you cannot do an experiment to test it. Period. I am tired of people telling me of their opinions, especially when you read, newspapers or online statements here. They say that they know this is the truth. The only thing we know about truth here is that experiments tell us the truth. And the truth is nature. We have to have objective reality of how things are. And it's the experiment that does that. It is by far the most important thing. People who are not scientists don't realize this. It's the experiment that tells us. So you can't have people who have difference of opinions because it's the experiment that tells you that. I don't care about your opinion. I care about what does nature tell us. When predictions have passed numerous experimental tests, only then do scientists call them theories. So when people say they have a theory, it's misuse of language in science. Theories are very, very powerful statements. People have hypotheses, and they make predictions from the hypothesis. And these theories, if they get really well tested, they become models. Models are the strongest picture of nature that we have. For example, there's the standard model of cosmology. It's called the inflationary model of the universe. It is super battle tested, really, really battle tested. I don't think there's a debate about it. Now, note, the model doesn't talk about the creation of the universe. It just talks about the expansion of the universe. That is not in doubt. Just like there's a standard model of particle physics. That is not in doubt. The model is super, super strong. Just like there's the standard model of evolution, right? Darwin's modified, theory of evolution is battle tested. But that occurs because they have passed numerous tests again and again and again. That's why I take, it makes me take a pause when somebody says they have a theory. No, you don't. You have a hypothesis. So the last thing that I want to do here is that I want to set a picture of how science works. And the way we do that is we talk about mathematics versus physics. As I've already said, physics is the fundamental study of nature. And what that means here is that we use physics concepts to describe a physical phenomena. So a lot of the times what you're going to see here is that when I say describe, I'm really drawing a physical picture. So in this course, you'll see that I draw a lot. That doesn't mean that you can't have a mental picture as well. Mathematical, in mathematics, you develop a mathematical picture in your head. Now, this physical picture takes on, many things. Like in this course, you're going to see here is that when we talk about motion, we're going to look at motion diagrams. And that's going to be a physical picture of how you describe motion. When we talk about forces, we're going to have these things called, they're called free body diagrams. And that's a way for you to visualize how forces interact. And then we're going to use bar diagrams when we talk about momentum and energy. And they keep going on and on. We build physical pictures. So from this physical picture, we now have a flow chart. What does that flow chart does? We start off with some physical phenomena. And from this physical phenomena, what do? We talk about the physics concepts and we develop a physical picture, just like I wrote up there. That's how we start physics. Then from here, we now start our flow. So as I start my flow, what you're going to see here is that then from this picture, we then write a mathematical equation. And when we write, the reason why we write a mathematical equation is because it's the universal language in science. And then what you're going to see here is that from here, we then solve this equation to get a number. Now that number is super, super important in science, okay? That number is super important. This number is extremely important. And the question is why? Because everyday language has words with double meanings. One example, this is a silly example, but it's the one that's coming off the top of my head. It says, hey, Carlos, you're a fat dude. Right? You're a fat dude. So what you probably meant in this situation is that you meant, hey, I'm unexercised a little bit or something, or I'm just heavy, right? But that's not the way I'm going to take it. I'm going to take this where you write it P-H-A-T, where I'm some rad dude. That's the way I'm going to take it. So the language of mathematics, right? Because this right here is the mathematics. And what you're finding here, numbers never have double meanings. For example, let's say that you measure the length of a pencil. So you measure the length of a pencil. So when you look at the pencil, here's the pencil lead. Let's say that you have a yellow pencil. And then here you have a red eraser. And then what you're going to do here is that you're going to take a scale and you're going to measure this, and it's going to read 15 centimeters. What's there to debate? The pencil is 15 centimeters. Everybody knows that it's 15 centimeters. Anybody can measure that and get 15 centimeters. So now when you look at the process of science, if you solve an equation, you get this number that's 15. So then you start moving backwards in the flowchart. Then you say, if this number 15 is what you get when you solve this equation, then it tells you that this equation must have been right because it matches up. But then when you keep going backwards, you must have had this physical picture in your head that's correct because you used that picture to write down the equation. This is the way physics works. Physics is not math. We use mathematics because it's a universal language. But physics is separated from mathematics. So I'll stop here and I will upload these things into the lecture page on Canvas so that you can use this for later on. So right now, you should be headed in towards your lab. Okay, thanks for showing up. I'm sorry for the problems with getting onto Zoom, and I will talk to you guys on Thursday. Okay, bye.